Well, hi, thanks so much for joining me as we talk about some key concepts for conditional probability that hopefully you picked up on in the previous videos and practice problems on con that you were working with. But in case you didn't, maybe this will help a little bit. So the first thing we're going to look at here is there are two examples of a tree diagram that we've got going on here. The first example is really heavy into the notation. So it can be a little overwhelming to look at, but let's just look at this one piece here. So notice this first branch is the probability of A. So this is just getting to A, okay? So now if we take this other branch, well, these are actually B, not B, B, not B, we'll call that A and not A. So if we look at, hang on, I had a thing, there we go, here's my thing I was looking for, a very technical thing here, this thing. So if we just look at this first branch, we have the probability of A and the probability of B. Well, how did we get to B though? Well, we got to B by going through A. So what happened here is A already happened, right? I'm going to go across the branch to A happened, and then we're going to go to B. That's exactly what this notation means. This is the probability that B happens given that A happened. So knowing that A already happened, what's the probability of B happening? So that's what this little tree diagram is showing for you. And then we have the same thing down, or a similar thing down here. A already happened, and now we want not B. It's a little weird they put the line on the top, but we'll work with it. So this is the probability of not B given A already happened. So this is how this given probability, what it looks like when we're on a tree diagram. And then we can come down here. Now we have not A and B. So this is going to be the probability that, this is backwards, by the way. Oh, no, I'm sorry. No, that's good. That B happened given that not A happened. And then this is the probability of not B given not A. So given just means this already happened. Notice both of these givens are A because that's what already happened. Both of these givens are not A because that's what already happened. Okay, so notation-wise, that's what's going on here. And then a little bit more applicable or a little more solid here. It's just an example of what a tree diagram might look like. So we're going to talk about primarily this one over here. But first of all, what is the formula to find conditional probability? Well, we need to remember that the formula for conditional probability is going to be the probability of A given B is equal to probability of A and B over the probability of B. Now, this is on your formula booklet. You do not have to memorize this. You just have to know how to use it. So some key points to point out, to look at here. This little line, that line means given. This is A given B. And this little guy here, that little upside, or that little N looking thing, that's the word and. Okay? So the probability of A given B is the probability of A and B divided by the probability of B. Okay? Now, something else we need to know about, when two branches share a vertex, what should they add up to? So if I have two branches that share a vertex, this little dot here, this is my vertex. So if I have branches that share a vertex, I need these probabilities to add up to what? Like if I have 0.2, what is this other probability going to be? Well, the two probabilities need, or all the probabilities need to add to what? So these need to sum or add to 1. So if one of them is 0.2, the other one is going to have to be 0.8, because 0.2 plus 0.8 is equal to 1, and that's what we need it to be. Now, most of the tree diagrams you're going to look at are only going to have 2 branches, but let's say we have 4 branches. Oh my god! All right, let's say I have like 0.1, let's say I have 0.2, let's say I have 0.3. What's this bottom branch going to be? Well, we got to remember, if they share the same vertex, they all have to add up to what? 1. So I need 0.1 plus 0.2 plus 0.3 plus what has to equal 1. Well, what's going to go in here? Well, 0.1 and 0.2, that's 0.3. 0.3 and 0.3 is 0.6. So that's going to be a 0.4. So that bottom branch is going to be 0.4. So keep in mind all the branches with the same vertex have to add up to what? Or 1. So now let's take a look at how to actually use these tree diagrams. When you trace a path across the branches, what do you do with the probabilities you pass through? Okay, well, let's take a look at my example up here. Let's say I want to get to that B naught right there. What's the path that I have to take? Well, I'm going to have to go across the 0.3. Ooh, if my pen will work, maybe, kind of. And then I'm going to have to go down to B naught. That pen's not going to work, kind of. Okay. So as I go across that path, what am I going to do with those probabilities? Well, this is A and B naught. So I'm going to multiply those. So we're going to multiply probabilities as we trace a path. Because we get A and B, or not A and not B, or whatever the situation might be. All right, so let's put these things together now. So how many paths do we get? How many paths are going to get us to a B? Well, let's look at this tree diagram here. How many B's do you see? Well, here's a B up here. Here's one B. Is there any other B's? Ah, actually there is. There's a B down there. So notice there are 2 paths that are going to get us to a B. We can have A and B, or we can have not A and B. Now, did you hear what I just said there? We can have, where'd my pen go? It's over here. We can have A and B, or not A and B. And if you can set it up and write it like that, now the math is going to work for you, because remember, A becomes multiply, or becomes add. I'm sorry, and becomes multiply, or becomes add, and becomes multiply. So as you go along these paths, what do we do with the probabilities? Well, we just set up here in number 3, we're going to multiply them. So I'm going to have 0.3 times 0.2, so I'm going to have 0.3 times 0.2, that's going to give me 0.6. I'm going to have 0.7 times 0.4, 0.7 times 0.4, this is going to give me 0.28. And so now I've got 2 probabilities that lead me to B. What do we do with them? Well, remember, I can have this path or this path. What do we do with the ors? We add these together. So I'm ultimately going to get 0.3 times 0.2 plus 0.7 times 0.4. And so when I get that, by the way, did you catch a little math mistake that I made here? I got a little carried away. What is 0.3 times 0.2? Yeah, that might be 0.06 actually. Hopefully you caught that and were maybe waiting for me to catch on to that one as well. But when we put these together, we're going to get 0.34. Okay, so that's kind of in a nutshell how all this conditional probabilities work. You've got to add going across. You've got to multiply going across, and then you add your results if you have more than one results, and then you're going to be good to go.